In this second video tutorial, we are downloading the free of charge laminator, Cura, developed by Ultimaker, and we will configure it in order to create a G-code file our printer can work with and then extrude it properly. Ultimaker is a prestigious manufacturing company which developed the well-known Ultimaker printer and which offers a free files laminator software. To download the free files laminator, we choose products in the website ultimaker.com. Here we can select software, Ultimaker Cura. We click that option and then we download for free. We will see a window and we click on the last option, I don't want to share any information, so that we don't have to fill in any form but only download the file. We click on download and we select where we want to download the software. We wait until it is completely downloaded and we install it. So we click on the downloaded file and we order its installation. We click on next, accept, and if we want, we can install it in the default file path of the main unit. Next, we leave all the options by default and we install it. We have to wait till it finishes to be able to execute the program. We'll be back in a moment. Once installed, we accept the option Execute Cura and Finish, and we wait till it opens. Now we have 4.0 version. First thing is to allow access to the private network. We agree, no problem at all. It is a completely free and legal software. We accept the user agreement, I understand and agree, and we select our printer. In our case, we do not have an Ultimaker printer, we have another. We are using concretely Creality CR10. We could also select Creality Ender 3, which is one of the other printers we use here. In the case your printer is not in the list, don't worry because we can create a customized one. CR10 has a 300 mm base and 400 mm height. If I selected custom, I would have to write the name of my printer and add my printer's settings. For example, I would say big printer, click on add printer, and I would see the settings. In this case, we are working in millimeters and it would be 300 millimeters base in its x-axis, 300 base in y-axis, and 400 in z-axis. We can leave the rest as it is by default, except for the heated bed option. My printer does have a heated bed and I will just have to select it. All this will be in the case I would like to set my own machine. We would not have to modify the rest and it would be correct unless we knew the features of our printer, which does not use a Marlin interpreter but Ultimaker, Rewrap, MakerBoard or any other. Our printer CR10 is Marlin based, which is an open source firmware and very popular because of this advantage of being completely open. I just have to click on finish and I will have my printer inside the software. Here we can see a visual display of the printing area of my printer. Down here we have another setup we can accept or deny, and which is the option to send anonymously to Ultimaker the use we are doing of their software. For example, to be able to check the defects and so that they can improve the following versions. I usually accept, allow. In the event our printer is already configured according to the printing options of before, we can go back to the previously mentioned menu through Preferences. If we click on Preferences, Configure Cura, we can select My Printers in Printers menu. You can see we can add a new printer and select again in Other, CR10. We click on Add, and here we have CR10, and we could choose between Big Printer, which is the one I added manually before, or CR10. I do not need Big Printer, so we can remove it. This window asks if we are sure we want to remove it, and we click on Yes. Another setting I can configure in Preferences in General bottom is the language. We can select English, German, Spanish, French, Italian. We are leaving the options and settings in English as it is considered the global language of communication. We click on Close. This software, Cura, is a laminator. Its function is to interpret a three-dimensional object and transform it to an object the printer can print. We are going to open the hand we created in the previous video tutorial. We open the folder, Downloads, and we select Hand Base Union and Open. The file is being now downloaded, and we will soon have it in our scenery. Right, so here we have our downloaded hand. First thing we have to be aware of is the fact our printer prints layer by layer and always from the bottom up. It is very important the placement of the object we want to print in order to achieve the best quality. If I printed my hand as it is now, we would realize the only part of our object in contact with the base is its lower section. The rest of our model is in the air. We can see Cura, this software, highlights this in red color. Why does this software highlight these parts in red? Simply because when printing this figure, there will be parts in the air, and as it is a hot plastic filament, we will have a bad printing as we cannot print in the air, and so we do need to use a support extractor. Supports are plastic from the plastic roll we use to produce the model, but used in a way it is easier later to remove it compared to the rest of the plastic, which will create our hand. We will see now when we explain some of the settings. On the left, we find certain settings that will allow us, when our hand has been previously selected, to move, scale or rotate our object. Mirror our object, for instance ordering a different placement of it, up or down. We can also block the object to decide its support structure. At the top of the screen, we have different options to configure it by default. In this case, we're using CR10 printer configuration. We are using a generic material, PLA type, biodegradable. As you can see, we can open this option and choose from many different well-known materials. It also gives us the information about the quality of the layer, the quality our hand will have when processed. The distance between each layer will be 0.2 millimeters. This model will not be completely solid, but it will be a 20% solid. This means in its inside it will only be a 20% filled. It will be hollowed in its other 80%. It also informs us we have not activated other type of support and we can work with more advanced options, as for instance adhesion, if we want to have a more improved adhesion. Adhesion is useful so that our model, and due to the fact the material is hot, but we might not have a completely hot bed, or it might have a defect and do not heat enough, so the object might unstuck. But we have adhesion option for this. There are several different kinds of adhesion which help us improve the adhesion of the print to the bed. We will see this in a more advanced course. We can preview how this hand will be laminated. We click on preview, we close this window, and we wait the laminated to be processed when we click on slice. Now an operation of slicing in layers is taking place. How many layers will we have? The software will calculate it as we order each layer to be 0.2 millimeters wide. We wait till it finishes. It is processing, and now we can see I'm getting much closer to the hand, how the software shows each of the layers. In fact, on the right side, we can see a bar that shows the very last layer, the one that finishes our hand. It is number 871. This means this object has 871 layers. We can move this to see how our figure is laminated part by part. The problem of this object, if we go back to prepare, we can see we had some parts of it colored in red. This is a warning the software points out, and highlighting it will have defects because it is a printing in the air. It recommends to use a support structure. This support structure, as we said before, is a plastic filament that will be processed to hold some pillars and which will hold those parts which are in the air, and we can activate it here at the top, either in prepare or preview. It makes no difference. If we click on off, this option here, support, and we set it, we could go through a new slicer, but now taking into account the support process. We wait for the operation to be completed, and we will soon see the result of it. The support is also made of plastic, and so it also has a cost. One of the things we must learn is to place our object so that the amount of plastic needed is the minimum. Let's see how much support it generates. As we can see, we now have support structure in all those parts that were in the air, and the software believes it needs so. How does most softwares of support structures work? It is quite simple. Fused deposition printers, due to its way of printing layer by layer and due to its Z axis, cannot print those parts in a 45 degrees angle. A 45 degrees angle from that position cannot print correctly the layers, and they are called suspended layers. This is the reason why it needs help of a support structure. We'll see now the color scheme. We're using yellow. We will select the options, for instance, of line type. We can see it here. Red is the part it will be printed, whereas turquoise is what they call the helper or supports. We can see the support structure is quite big. Another important information this software provides us is the approximate number of hours this model will need to be processed, to be printed. In this case, it will take 21 hours, 59 minutes to be done. Too many hours from my point of view. And this is due to the placement of the hand and the base. We can also see we will spend 320 grams of plastic material. This is an approximate data, and it can vary depending on the support structure. The amount of time depends on our printer and its acceleration settings. We are placing this model in a different position in order to try to reduce the amount of support structure and the number of hours. It states it will last 21 hours and we will use 320 grams. Let's go back to prepare, and we will rotate our object so that the base is flat at a 19 degrees angle. We are going to order support structure and a slice of it. We wait a moment. This process can last more or less depending on the complexity of the figure. Its complexity depends mainly on its polygonal load and on our model's shape. It is still processing it. We'll see if we use more or less plastic material depending on a smaller or higher support structure, and we will also see the amount of time it needs to be processed. Well, it now states it will take 1 day, 24 hours and 53 minutes, and it still needs 350 grams. We see we have a similar number of hours, and now we have even a bigger support structure. What can we do now to find the way it needs less amount of support in its finish? If we leave the hand in this position, the base is better settled and the print will be more precise and correct in the upper part of our hand. But the inside of it, which will be the part it will face us in the case we stick it to the wall, might need a better post-processing. Sanding it, using a bottle of spray to cover any defect it might have, sand it again, repaint it, use a cracking filler, and so the post-processing can be much longer. Is it useful then for us printing our hand in this position, or we should try other option? Let's try other possibilities. Let's try to reduce either the amount of time and the amount of filament needed. We go backwards, we select our hand, and we tilt it to this position. Let's see what happens if we place our hand this way. We see now the contact surface is smaller. That's why we're going to use adhesion, an option to better adhere the contact of our hand and the base, and we order and slice. We will see another result. We wait for the process to take place. It is slicing it, and we will see if this position is interesting for us. Let's see its preview. In preview, it is generating its slice. We can see now its support structure is much smaller, and also the number of hours is different now, 16 hours, 1 minute. This is a much better option than the one we had before. The only problem we can find in this design is that due to our model's height, it can separate from its base. That's why we have established an adhesion base. If this is the final position we choose to print it, we should click on Save to File. Here we decide where we want to save it. It automatically names the file, but with the prefix CCR10, which is the machine we selected in Cura configuration, Creality CR10. The file will be G-code format. A G-code file is an alphanumeric file, text and number, which this software generates and which indicates the printing coordinates and the amount of plastic our machine needs to extrude to print this model. This is the file we will have to send to our printer in order to start printing it. I'm going to save it. As you can see, this software is quite simple and easy to use when working with it as its basic mode. We have a more advanced setting for this software. We have it here, as you can see. Prepare, preview, and a monitor option if we have our printer connected to the computer, to our PC. We have really easy options here, really simple to manipulate, but it is not always the case. We also have advanced settings. In fact, working with Cura, one of the settings we have is at the top, Custom. If we click on this button, we can change all the already established settings for more professional ones. We have the quality of the layer of the outside part of our hand, commonly known as shell. The infill, on the other hand, is the inside of our hand. The material button refers to the material we are using, PLA in our case, and the temperature we are using to extrude it, 200 degrees, and also the temperature of the bed, 60 degrees. We can change any of these settings as we please, as for instance its support or build plate adhesion. Let's check its adhesion. It is a BRIM type adhesion. BRIM is what we saw in preview, specifically these turquoise areas at the bottom of it. This turquoise ring here, this is what we call BRIM. We have another option, Raft, which is more advanced. Let's see it. Raft is a support structure appropriate for objects like this one that can be delicate to print, as its height and inclination could make the object to detach from its plate, ruining all our printing process, which takes many hours. We can define a more stable adherence to the bed. This implies more plastic spent and more time, but it is a more secure way when adhering our model to the bed. We now see it will take us 16 hours, 26 minutes, and we will be using 245 grams. We can also vary its support. Here we have the options of generating its support structure, its placement, or its angle. It is a 50 grades, although we said before a 45 grades angle. Here establishes a 50 grades angle, which is an appropriate one. Lower than 50 will give us problems. The cooling of the layer is another of the options we have. This makes the layers to cool when they are being created. When using PLA, we strongly recommend to set it at 100%. The cooling device must operate at its maximum capacity, as PLA must cool fast. This does not happen with other plastics, as ABS for instance. We can also change the speed of the printing process. It is not our advice to use a 60 millimeters per second speed, 50 millimeters per second maximum. The best for most of non-professional machines is from 40 to 55 millimeters per second. CR10 works really well with a speed of 50 millimeters per second. If we change this option and slice it again, the time will be greater as it lasts longer to do the layers. The PLA printing temperature is chosen by its trademark. We are now using a PLA filament trademark that extrudes much better at 210 degrees, and so we have to change it here. 210 degrees. We can leave the plate temperature at 60 degrees, which fits really well PLA. We also have the quality of each layer, 0,2. There are 3 types of quality: 0.1 for the best quality, 0.2 for a normal quality, and 0.3 for a more vulgar quality, we could say for a quicker printer with a worse ending. We can also set the external part of our object, which is defined through shell. In this case, we can see the wall is 0,8 millimeters. Our advice is to set it at 1.2 millimeters. That will make our wall have 3 lines count, as our extrusion is usually 0,4 millimeters. That is, we will have 4 times the width of our extrusion point, which makes our model more rigid. The rest of the settings are correct. We will have to decide a few more settings, as the thickness of the top and bottom layers. The top-bottom thickness, in my opinion, should be 4 times its layer height if it is 0,2, and 8 times if the layer height is 0,1. 4 times is 0.8, so we will set here 0.8 for top-bottom thickness. If the layer height were 0,1, the maximum quality of the printing, here we will set instead of 0.8 around 1.4 or 1.2. 1.2 will be fine. I very often print at 0,2 or 0,2 unless I need an excellent quality. We slice it again. We wait the whole process for this model, and we will see the number of hours. Of 16 hours and a half, we will see that number will increase. The extruded plastic will not vary too much, only a bit more as we used a raft, and we will see the final result when the process finishes. We have gone from 16 hours 20 minutes to 20 hours and 6 minutes due to raft and to the height of the layers, regarding the amount of shell, and also regarding the number of layers we want our model to have. We select the object and we can see the final result ready to be saved. We can choose then this position of our hand. That will need many more hours of printing, but it will have a better quality and we won't have to post-produce it much. This is the recommended option. We can save it overwriting the previous one, and the next step will be sending the final file to our printer.